So, a pleasant day to each and everyone. My name is Princess Len Aitisado, and for today, I will discuss the history of two things, which is the telescope and gravity. So first, let's talk about the telescope, which is one of the key scientific instruments that has changed our perceptions of the world. So let's define what is the meaning of it. It is a simple device intended to enhance vision, making distant things appear closer. It is so useful and versatile for use on land and also at sea. Not only have many different types of telescope been made in the last 4 centuries, but telescopic enhancements have also been used on many other instruments and accessories. So now let's talk about the history of telescope. So historians are not absolutely sure who invented the telescope, but it is known that in 1608, a Dutch spectacle maker, which is Hans Lippershey, announced a new lens-based seeing instrument that made distant objects appear much closer. This is the first evidence we have of the invention of the telescope, the first scientific instrument to extend one of the human senses. So, his telescope had a concave eyepiece aligned with a convex objective lens. So, he got the idea from a story, which is that he observed two children in a shop holding up two lenses that made a distant weather vane appear closed. Others claim at that time that he stole the design from another eyeglass maker, which is his name is Zacharias Janssen. So, Janssen and Lippershey live in the same town and both work on making optical instrument. Scholars generally argue, however, that there is no real evidence that Lippershey did not develop his telescope independently. So, Lippershey therefore gets the credit for the telescope because of the patent application, while Janssen is credited with inventing the compound microscope, and both appear to have contributed to the development of both instruments. Since then, the telescope has evolved as a key scientific instrument that has changed our perception of the world, just like what I said before, and the universe around us. It was in astronomy, in particular, that the telescope had an innermost impact, starting with the discoveries of Galileo Galilei, whose work began to change our understanding of the universe. So, Galileo heard about Hans Lippershey's ingenious device via his French associate, Jacques Bouvier, in 1609. He immediately set about designing and building his own telescope, although he had never seen Hans' device. Nonetheless, he was able to make significant improvements on the performance of his telescope, reaching magnification of around 20 times. Pleased with this creation, he subsequently presented it to the Venetian Senate, who rewarded him by making him a lecturer at the University of Padua for life. As impressive as this was, he went further. As history attests, Galileo is the first recorded person to point his telescope toward the sky. Despite this, Galileo became known for his finding from his telescopic observation. This included, which is the Jupiter's 4 moons, the Earth moon was not spherical, the terrain of the moon, and its similarity in geological makeup to Earth. The sun was the center of the universe and not the Earth, as people thought. So the telescope continued to evolve, and in 1611, the Keplerian telescope was born. After the groundbreaking work of Hans Lippershey and Galileo Galilei, other scientists around Europe began to design and build their own telescope. Chief amongst the early pioneers was the one and only Johannes Kepler. So, Kepler made detailed studies of telescopic optics and devised his own apparatus with two convex lenses, the famous Keplerian telescope. He built one in 1611, While the design greatly improved the device's magnification, it also rendered the observed image upside down. So, apart from his significant contribution to astronomy, he was instrumental in the field of optics and general. His groundbreaking manuscript, Astronomia Pars Optica, would earn him the title of the founder of modern optics. This book contained his observation and rationalization about many aspects of optics, including the use of pinhole cameras to take pictures, explanation of the refraction in the eye, and his understanding of the depth perception. In a later work, Dioptric made him the first person in history to describe real, virtual, upright, and inverted images and the concept of magnification. He would also become the first person to explain how a telescope actually works. So, Kepler also discovered the properties of total internal reflection. So, that's where Isaac Newton built the first reflecting telescope. So, Sir Isaac Newton would later build on the work of his predecessors, notably Kepler, and reasoned that telescope should use a series of mirrors rather than lenses. He believed, amongst other things, this setup would solve the chromatic aberration. So, chromatic aberration, it is a phenomenon in which light rays passing through a lens focused at different points, depending on their wavelength. It is a common issue that plague reflecting telescope. So, he also believed that this issue could never actually be cured using refracting telescope. That's why he find himself a new solution. So, following through on his thoughts, the first reflecting telescope, which is the Newtonian telescope or the reflector, was built in 1668. Newton's breakthrough was to use a large concave primary mirror to focus light onto a smaller flat diagonal mirror that projected an image into an eyepiece on the side of the telescope. So, contrary to the popular belief, Newton was not the first to devise the idea of a reflecting telescope. Because Galileo Galilei and Giovanni Francesco Sagredo had also discussed the possibility after the invention of their refracting telescope. And also, other scientists at the time like Niccolo Zucchi may have conducted similar experiments in 1616. It is also possible that Newton read James Gregory's 1663 book Optica Promoted that had a description of the concept of a reflecting microscope which used parabolic mirrors. So, Newton's telescope would prove to have a number of advantages over existing models of the time. So, there is no chromatic aberration, cheaper to build, construction and assembly was a lot simpler, wider field of view due to short focal view, and the design was much shorter and more compact than its predecessors, making it more comfortable or portable. And one of the greatest discovery in telescope history is the Hubble Space Telescope, and it was a massive milestone. In 1990, NASA and the ESA cooperated to build and deploy the Hubble Space Telescope, making it one of the first telescopes to be launched into space. Although it was not the first space telescope, Hubble is one of the largest and most flexible. Since its deployment into low Earth orbit, it has taken part in many vital research projects. Liberated from the distortion of Earth's atmosphere and background light, Hubble can provide very clear images of the stars and planets that are unparalleled. The telescope consists of 7.87 feet or 2.4 meters, mirror, and a suite of other instruments to observe near UV, visible light, and near IR spectra. Over 30 years of operation, new cutting-edge scientific instruments have been added to the telescope during astronaut servicing missions. This has greatly extended the telescope's lifetime, and it is expected that Hubble could be able to stay in service well in the 2030s. So, looking back, it was so amazing that from the first designed telescope and to Hubble telescope, it continued to evolve that provide the means of collecting and analyzing radiation from a celestial objects, even those in the far reaches of the universe, that before it seemed so far and now making it easy to reach. It was so reachable right now. So now, let's move on and talk about the history of gravity. So, the legend is that Newton discovered gravity when he saw a falling apple while thinking about the forces of nature. And why he named this force gravity, because it comes from the Latin word gravitas, meaning weight. So, Newton realized that every object in the universe attracts every other object in the universe. So, whatever really happened, Newton realized that some force must be acting on falling objects like apples, because otherwise they would not start moving from rest. So, he also realized that the moon would fly off away from Earth in a straight line tangent to its orbit if some force was not causing it to fall toward the Earth. So, the moon is only a projectile circling around the Earth under the attraction of gravity. So, Isaac Newton compared the acceleration of the moon to the acceleration of objects on Earth. This comparison led him to conclude that the force of gravitational attraction between the Earth and other objects is inversely proportional to the distance separating the Earth center from the object center. So, Newton knew that the force that caused the apple's acceleration or gravity must be dependent upon the mass of the apple. So, for Newton, the force of gravity acting between the Earth and any other object is directly proportional to the mass of the Earth, and also directly proportional to the mass of the object, and inversely proportional to the square of the distance that separate the centers of the Earth and the object. So, since the gravitational force is directly proportional to the mass of both interacting objects, more massive objects will attract each other with a greater gravitational force. So, as the mass of either object increases, the force of gravitational attraction between them also increases. So, for example, if the mass of one of the object is doubled, then the force of the gravity between them is also doubled, and so on. Since gravitational force is inversely proportional to the square of the separation distance between the two interacting objects, more separation distance will result in weaker gravitational forces. So, as two objects are separated from each other, the force of gravitational attraction between them also decreases. If the separation distance between two objects is doubled or increased by a factor of 2, then the force of gravitational attraction is decreased by a factor of 4, 2 raised to the second power. If the separation distance between any two objects is tripled, then the force of gravitational attraction is decreased by a factor of 9, 3 raised to the second power. So, in 9.81 meter per second squared, it means that the object on Earth will accelerate or go faster 9.81 meters every second if they are in free fall due to the pull of gravity. Throughout the space gravity is constant. So, gravity is very important to us because we could not live on Earth without it. The sun's gravity keeps Earth in orbit around it, keeping us at a comfortable distance to enjoy the sun's light and warmth. It holds down our atmosphere and the air we need to breathe. So, that's all. I hope you learned something from it, and thank you for watching. Have a good day.